So just to remind everybody, we covered Burns et al. With the field deployable structures. I think there's been a lot of say chatter in the chat column here with some general questions about the resiliency of cables, deployability by rovers or other assets, and imparted shape memory from storage. Dr. Burns, did you want to comment?
Yeah, and I responded to some of that in the chat as well. My point being is we've come a long way since the Apollo era with the flat ribbon cables, which we're all familiar with, got tangled up early on in Apollo and the astronauts tripping over them and so forth. So we've done a lot of experimentation in collaboration with our colleagues at JPL using polyamide film tethers with cables. Embedded within them. And we find with these more modern materials that they're able to do a better job of laying flat on the surface, not tangled up in the same way, and to unspool more smoothly and flatly on the surface. The kind of tethers that we're talking about using now are at the TRL level 5 to 6, so are pretty well determined at this stage. There was a question though asked about astronaut tripping over because we saw plenty of that during Apollo. And so in thinking about this a little bit with the deployment device, I showed in the cartoon just an astronaut, pushing a roller. You could easily envision that being pulling instead, so that the astronauts would be out front of this. But it's important to have some training associated with it. The gravity environment on the moon is going to be more challenging to be able to do this. So I think we need some serious training that will be necessary to be able to do this. Finally, there was a question asked, can we do this with rovers? And the answer is yes. That was our original concept, was to do it with rovers. But in the case of Artemis, by not having a rover, you significantly reduce costs and risks, and having the astronauts available right there to do some problem solving in real time, particularly with respect to connecting the tethers then to the power and to the communications, I think is a real plus to use human hands rather than more cumbersome robotic arms. So, Mike, I think I addressed a number of the questions, but there may be more out there. So,
no, there was.
Mike,
go ahead.
This is Jack Schmidt. Jack Burns, go back and look at the experience on Apollo 14, and with a hand pull roller. Certainly, an LRV or an LTV is a good solution later on. But hand pulling a rover with the depth of the soft regolith being 5 to 10 centimeters, that just doesn't work very well. And we tried that on 14, unfortunately.
Well, we'll take a look at that again, Jack. I did look at that early on. And so I think it's a good point, and one that we'll continue to look at. I think it depends somewhat on the site that we're going to be talking about.
Well, that loose regolith right at the top means you're pulling against it. And we tried to talk Alan Shepard out of that. He wanted it. It was a major task for him to use that. So just look at it again.
All right, we'll do. Thanks.
Okay. So for Dr. Graham, there were a couple of really interesting comments. One from Dr. Rummel regarding water activity of PSRs. And so where we might have water, it might not allow for that phase to be used by the life. Do you have any comments?
Yeah, no, that makes a really good point. And, that's why I was trying to emphasize that we're thinking about an array of conditions that these microbes can take, with just spore survival in an area that is topographically protected from radiation and excess temperatures, where that becomes basically a chemical contamination problem. He's absolutely right. this water may not actually be available. There's certainly a lot of nutrient and energy complications, so that we probably wouldn't be moving over to that lifey end of the spectrum that I showed unless there were big grand changes made to the surface of the moon. So this becomes a way of thinking about, if we know that these were places that could have conferred survivability to any organisms that we might have taken with us, we would want to have caution about how we modify those places then as well, if we think that we may be modifying it in a way that it suddenly moves from being just a survivable niche to an actual habitat, which is, on the dorm room fridge end of things. I also wanted to say that a lot of people had questions about spore viability and survivability and radiation and things like that. And, we're looking into studies like that. You'd be surprised how many studies don't really talk about many of the organisms of interest that we're thinking about. And we also don't understand lower temperature limits for a lot of these organisms, even the spore formers. So there's a lot of room for us to think of future research around this topic, as well as what we're trying to find in the literature right now.
Yeah, that was going to be my follow-up there for the probability of survival with cosmic ray exposures and spores, but I think that's a very good comment. For Dr. Viswanathan, can you talk a little bit more about the significance of a polar reflector in terms of being able to do that geodesy? That instead of having equatorial bands of these retroreflectors, adding that polar one to measurements.
Right. I think there are a couple of things that are interesting. I mean, all the current reflectors are in that north belt, right? And it does provide, the current ones do provide like a very longitudinal sensitivity, and that's great. But we also have a slight latitudinal sensitivity in terms of librations. And the reason like a polar retroreflector would really add to that. The second thing is that the sensitivity is along the line of sight, right? So we can think about some of the effects that we spoke about here, like colleagues regarding contraction and the horizontal displacement love number, like L2, for example. They would provide some modulation along in that direction, and that's fantastic for measuring a south polar reflector will definitely contribute to that. And so I did mention, so there are a couple of things more, and if for those curious, please feel free to look at some of the white papers that we put out for both the SDT report as well as the decadal survey, where we brought about the community and try to understand what are things that we can really benefit from by placing retroreflectors, not just in the poles, but spread out. So thank you.
We have about a minute and a half for more questions. There was one that spoke or stood out for me from another for Jack. How sensitive is that method to a planar configuration, or what?
Yeah, that's a good question, and it's not very sensitive at all. For one reason, we're dealing with very long wavelengths, 10 meters or longer, and so inaccuracies in the placement of the individual dipoles is not very important. Furthermore, we're going to use astronomical techniques, namely looking at radio sources in the sky to then actually measure the placement of the antennas onto the surface. So exactly where they are, both in terms of the XY coordinate as well as the Z coordinate above, but any changes in elevation, we can actually calibrate that out.
Any other questions from members on the in the audience? Okay, then I think we can close this session out. Very entertaining. I still have a lot of questions. but we'll turn it back over to Sam and others.